Hello, and I'm John Rutger. I had section 3.3, problem 8. In this section, we're talking about regular singular points. Here, they're wanting us to use the point where x equals 0, and I tell what kind of point that is. So, right away, this is not the same equation given in the book. I took the 6x squared plus 2x to the third, and I divided that across the whole equation, and this is what you should have. So our big P of x is 21 over 6x plus 2x squared, and our big Q of x is 9 times x squared minus 1 over 6x squared plus 2x to the third. Well, we can hopefully see that the point x equals 0 is non-existent, so the limit as x goes to 0 will actually go to infinity, since you can't divide by 0. So what we're going to have to do then is find the little p of x. Since this is not an ordinary point, we just proved, we're going to see if it's a regular singular point or an irregular singular point. We're hoping it's a regular singular point. Probably will. So our little p of x is equal to x times the big P of x. So timesing this by x, we'll see that this x will go away and this will become x. So our little p of x is actually indeed equal to 21 over 6 plus 2x. Now, the next thing we need to do is find our little q, which is our little q of x is equivalent to our x squared times our big Q of x right over here. Multiplying this by x squared, we'll see that this x squared will be gone and this will become just x. So it's going to look a lot like this. So our little q of x is going to be indeed equal to x times x squared minus 1 over 6 plus 2x. Now we need to find the limit as this goes to 0, and we'll see that the limit as x goes to 0 of our little p of x is 21 over 6 plus 2x. So this x is going to cancel out, so we're going to have in the end 21 over 6, which is equal to 7 over 2. Now we need to find the limit as x goes to 0 of our little q of x. I'm going to write out 9x squared minus 9, distributing the 9, 6 plus 2x. This x and this are going to be gone, so we're going to have this equal to negative 9 over 6. This is equal to negative 3 over 2. That actually looks pretty nice. Since these are existent, we can now say that x of 0 is a regular singular point. The next part of the question says, if it is a regular singular point, find the exponents of the differential equation at x equals 0. So now we're going to have to use the indicial equation. That's given as r times r minus 1 plus our p of 0, which we just found, or p naught, times r plus our q naught, which we just found also, and that's equivalent to 0. I'm going to put that in and write it out for us. So r times r minus 1 plus our 7 over 2 r minus our 3 over 2 equals 0. Well, there's a lot of ways you probably can approach this. The way I'm going to approach it is multiplying this equation by 2 and then distributing this r into here. So in the next one, we're going to see that this is going to indeed be 2r squared minus 2r plus 7r minus 3, and that's going to equal 0. Well, think I'm going to put this into a easier way to see this, because I'm seeing right here we're going to have a 6r, and this could be a negative r, and that will lead us to having this 2r minus 1 multiplied by r plus 3. If you don't see that, or you had to do it another way, you could use also the cubic equation. So let's, or the, not cubic, the root equation. So we'll have 2r squared minus r plus 6r minus 3 equals 0, and this indeed will be 2r minus 1 multiplied by r plus 3 equals 0. And now we can see that the exponents of the equation at x equals 0 will be, our r's are going to be equal to a half, or negative 3 is what our r is. So that will be the exponents of the differential equation at x equals 0. Hopefully this video was helpful, and now you have a better understanding. Subscribe.